So last day, which we'll really be doing new material, might bleed over a little bit of instrumental variables into next week, just looking at more examples. But we should kind of have everything that we'll need to know after today's class. Like I said, I might just work through some more examples as part of review, but next week is primarily just going to be review for that final. So I've already got this up on Canvas, kind of have that formula sheet you'll have in the final exam, and then the practice final would be a good thing to kind of start using to study. Now, obviously, all these old practice sample questions, all the old quizzes, those would be good. Now, I say all of them. Really only everything since the midterms, so the last 3 quizzes and then 3 sets of practice problems will be what I would expect you to know on the exam. So it's not cumulative in the sense I'm not going to ask you like, week 1, week 3 type questions, but it is comprehensive in that we built on everything this semester, right? So those last 3 sample questions, so 4, 5, and 6, last 3 quizzes, 4 and 5, 6 was really going to be just this one, which was opinion based. So I kind of showed you this on Tuesday's class. Should be really easy to get. Pretty, all the points here. This is just going to be things about the class. So no right or wrong answers. So as long as you get on and get this done, you'll get the kind of full points there. And the only other thing that we have left is, where is it at? That 6th problem set. Okay. So the first half of it was all panel data stuff. The second half is instrumental variables. So you probably could get pretty far on it already. After today, anything that remains, it shouldn't be too bad. I tried to write it in a way that there isn't as much coding, or there shouldn't be as much work as maybe some of the other problem sets. We'll kind of finish up anything questions you might still have today. Okay. Other than that, just as a reminder, as we get close, final is Tuesday in the middle of the day, right? 12:40 to 2:40. So I believe we'll be in the same classroom, so it shouldn't be a problem finding it. Also, after today's class, I don't know if I'll get it done before I leave today, but for sure tomorrow, I'll update Canvas so that it reflects that your 2 lowest in-class quizzes have been dropped. So it just takes your 10 best. So as long as you've been coming to class, like honestly, at a decent rate, you should be able to get a lot of those points there. But I don't have that reflected yet. It's still kind of counting all of those quizzes, but I'll get it updated so that it's dropping your 2 lowest. Okay. Other than that, any questions for me before we kind of dive back into things here today? Okay. So I'll go through the slides, even though we went through them a little bit, just to kind of recap where we were. So we had this instrumental variable approach, and we said it was a solution to things like omitted variable bias, some simultaneous causality, or some of our measurement error issues. So here, really what we were looking for is we had 2 terms. We needed a good instrument, we said, to be endogenous, right, which means like part of or to have an effect on our X variable. We need it to be exogenous if it's uncorrelated with our Y or our dependent variable. So here were kind of our 2 requirements. We need it to be endogenous to X, so that covariance needs to be something other than 0. Now we want it to be exogenous to Y, so we would want that covariance of the error term from our regression, which is part of Y, everything that was in Y that wasn't explained by X. So inherently, this instrument, if it's impacting X, then yes, it's going to impact Y, right? Y is a function of this variable X. However, we would say it's exogenous if the only way that instrument impacts Y is only through impacting X. It doesn't impact anything else that would be explaining Y. So anything else in that error, right? Remember, when we write this out, what's in the error term? Everything that we haven't controlled for. So these are our 2 conditions that we want to have met. We said, how can we do this? And this is the question. Why am I using pi here just to differentiate between the 2? We're going to run 2 regressions. Now, part of what Stata will do is do a lot of this behind the scenes for us. But I showed you last class how to do it manually, and we'll look at it again here today. I'm first going to take my X variable that I'm interested in. So what I'm really interested in is the impact of X on Y. So I'll run a regression where I instead put X as my dependent variable, and I run as my kind of control, or my independent variable there, my instrument Z. Once I run that regression, I will use the coefficient estimates I come up with to predict different values for X. So I have the actual X values. I'm going to use that first stage regression to come up with the predicted X values. Okay. Then in my regression where I was really interested in what was the impact of X on Y, instead of using the actual X values, I'll use the predicted X values that came from the predictions using my instrument. Okay. If I do that, I should end up with a coefficient estimate that is then unbiased, right? It's eliminated this measurement error, it's eliminated variable bias, etc. So once again, we'll look through more examples of how we do this. This is kind of where we left off. But another thing that ends up being kind of interesting, we'll take a look at this in the data. So I want to go through some of the topics and then we'll really get heavy into this data here, is if I think about how could I come up with that coefficient estimate for beta 1. So it's going to be the covariance of y with z, and then the covariance of everything on the other side with z. So that would be, we're thinking about going back to like our very basic definition. If we had a simple linear regression, we said our coefficient estimate was the covariance of x with y over the variance of x, right? Well, here we're kind of going to do that same thing. We're just rewriting out kind of what y is, right? So covariance of y with z, here's kind of my equation for y. And I'll start to think about what would the covariance of z be with each one of these things, okay? So I'm just kind of giving you the mathematics, but I won't make you do this proof, but this would be the proof as to why what we're going to show you is going to work. So what should the covariance of my instrument be with just the intercept? The intercept is a constant, so the covariance of that with my instrument should just be 0, right? What about the covariance of x with z? Well, if it meets the endogeneity condition, I know that will be something other than 0. Now, if it meets the exogeneity condition, we said the instrument should be uncorrelated with everything in that error term, so that should also go to 0, right? So I'm just going to redistribute this, pull that coefficient. It's just a constant value up front. And what I end up with is this equation. Well, notice if I want the coefficient estimate for beta 1, I can actually now have an equation where I can solve for that. So beta 1 simply becomes the covariance of the instrument with my y variable divided by the covariance of the instrument with my x variable. So we can actually go ahead and prove this to ourselves with some data once we kind of start looking at things. So we'll kind of keep this in mind, that we can actually calculate the coefficient we would see from an instrumental variable regression, two-stage regression, by simply doing this. Now, we can't do this if we start to run regressions with additional controls. So that's going to be a problem. But our very simple linear regressions without any other controls, we just have that one x variable, this will work for us. We'll kind of see this play out here in just a second. So we can do the exact same thing, but include not only this variable x, we can include w, which is like all these other controls, right? And we would still be able to run that first stage regression, run the second stage to use our predicted x values, and just use those controls in both our first and second stage regression. And instrumental variable approach should work. So we'll kind of look at this as well. If we do this, however, we can't use this simple equation because now, if I'm looking up here, I've got like other controls, and there the instrument might be correlated with the other controls, and that doesn't quite hold. Okay. So we'll take a look at this before we start to talk about weak instruments. So we were looking at this example last class. I've got this file opened up. I'm going to come down here. And here I said, this was last class, what you can do is run the first stage, right? So here my Y variable was health insurance. And this was like the state level Social Security income ratio, how much money they gave you, replacement income they gave you, right, once you retire. And then once we run that first stage, we'll come up with our predicted health insurance variable. That's what we're actually going to include in the second stage, where we're trying to kind of predict that relationship between medical expenses and health insurance. We'll use predicted health insurance. And I think maybe to make the names make a little bit more sense here, if this helps keep it a little bit more clear, this is our predicted health insurance. That was just the name of the variable that we're creating. Okay. So I can run this first stage regression. And I see that here's my coefficient. It's statistically significant. So it looks like there is some correlation between my instrument and my X variable of health insurance. My second stage, my second stage regression, I can use the variable I was interested in predicting, my medical expenses, and those predicted X values from my first stage regression. Now notice here, this is an example where I've used all of those, I've used some other controls as well. So I don't just have to do this with only one X variable, I can include additional controls, right? It's just that when I'm coming up with my predicted X value, it's only of the variable I'm interested in eliminating the bias from. So if I run this regression, for instance, so here's my second stage regression now using those predicted X values, I've eliminated the bias that exists in that variable that I made predictions for. All my other controls could still have bias. They were just things that I was able to control for these other factors, right? And so one condition that we said had to be met was that our instrument has to be uncorrelated with that error term. Well, if I don't include any other controls, what's in that error term? A lot of things. As I start to include more controls, I'm pulling those things out of the error term. Is it going to be more or less likely my instrument is not correlated with that error term? Less likely. So controls still matter is the end of the story, right? We still want to control for as much as possible because that makes it more likely that that exogeneity condition is met. So here I've got my estimate. It should be an unbiased estimate here, but I want to kind of show you a different way of thinking about this and just write it out, not just with code, right? So we were trying to look at this relationship between whether someone had health insurance and what their medical expenses were. And we had a bunch of additional controls as well. So our first stage, what we were going to do is replace, I shouldn't say replace, but use our X variable we're interested in as our dependent variable. Excuse me. And then here, we were putting our instrument, which was that Social Security income ratio. Now we still have to include kind of our additional controls here, right? And then in that second stage, we're going back to the original regression that we wanted to know the relationship between medical expenses and health insurance. And here I'm writing everything as beta, so it would get tricky. I'd probably should put like beta first stage, right? Because they're technically different values here. But then I'm going to just plug in. So here I'll come up with, from this regression, my predicted X value, and then all of my additional controls as well. So I'm running this regression, coming up with these predictions, using those predictions in my second stage. Okay. So when I'm thinking of instruments, and here, I actually think I'm going to show you a second one, which was not just the Social Security income ratio, but this was, I think, like distance to healthcare facilities or like the number of healthcare facilities. What we need is our instrument Z to be correlated with our X variable, but uncorrelated with our Y variable, or technically uncorrelated with anything in our Y variable that we haven't controlled for, right? Anything other than the X variable we're looking at and all these additional controls, right? So technically there is uncorrelated with the error term, but it's just as easy to think about it as uncorrelated with anything that you haven't used to explain Y. So uncorrelated with anything that's in Y that you haven't controlled for, okay? Any questions on this idea? Okay. So we look here, right? I've got my first and second stage. If I were to run that naive regression, we'll notice I would have come up with a coefficient of negative or 0.075. So we said it changes it quite a bit, right? We've eliminated a huge omitted variable bias, right? So we should be getting an unbiased estimate here. So we can save time, and I showed you this last class, but kind of using this IV regress command, it'll run the first stage for us and the second stage all at once, come up with the predictions behind the scenes. We don't have to worry about doing it by hand. So here, I kind of gave you the general form. We have to say IV regress 2 SLS. We're doing 2 stages. Here's my Y variable. here's the X variable, here's my instrument Z. Okay. And then I can include additional controls. Okay. So I'm actually going to run both of these, and we're going to think about, okay, what was a better instrument here? So I've got my Social Security income ratio. That was my first instrument. And then I'm going to try a second instrument, which was like, that's what I was saying, that healthcare expenditures location, like how close was the nearest healthcare facility? So that should, why would that be a good instrument? So if I'm thinking about, I'm still trying to predict the same thing, which is the impact that health insurance would have on medical expenses. So if I've got this firm location, so this is like the distance from where you live nearest healthcare facility, do you think that's going to make it more or less likely that you get health insurance? Might not seem like much, but if there's somewhere really close by, right, a company you can actually get health insurance through, these are likely going to be correlated. But does a health insurance firm just simply being located closer to where you live impact your medical expenses at all? Only through whether or not you have health insurance, right? Everything, I can't think of a scenario or a story where that firm location is going to impact your medical expenses through anything else. So it's likely we have that second condition met as well, which is that it's uncorrelated. So this looks like a good instrument. Okay? So we'll run both of these regressions and see what we get here. Okay. So notice from that first regression, when I'm using that Social Security income ratio, we had a coefficient where we eliminated the bias was negative 0.85. The second one, it's not quite the same coefficient. And that's because maybe these aren't perfect instruments, right? Maybe they eliminated some of that omitted variable bias, but maybe one of them is a better instrument than the other. And so maybe it eliminated more bias. Okay. So if I'm looking at this just from my second stage, I really don't have a good indicator for which of these is going to be a better instrument. So we'll talk about some things we can look at here in a second to identify, well, we probably want to identify what we're using the best instrument possible, right? So I'll come down here where we think about, do we have kind of weak instruments? So, yeah.
Can you not just look at the p-values? Is that like?
So what would these p-values tell me? That's going to be this. The test statistic?
Yeah.
You could, I mean, they're going to go hand in hand, right? The test statistic's higher, but just because this has more statistical significance, that's not necessarily an indicator that that's a better instrument. Okay. So that's just telling me the correlation between the predicted X values and my Y variable. Okay. It's not necessarily that the higher one is going to be better, or the higher test statistic is going to be better. Now we'll talk about here what would be. Okay. So do we have weak instruments? So the thing that actually tells us what that correlation, or if that's a better instrument, it's hard for us to come up with a measure of whether or not it's a better instrument in terms of does it meet the exogeneity condition. But we can come up with a way to see, does it meet that endogeneity condition better, right? That's the one we want to be able to test. So if we look at the F statistic from our first stage, so that's where we were trying to predict our X value health insurance with our instrument. Well, the F statistic from our first stage is going to tell us kind of give us a test statistic for the amount of the variation we're explaining in X with our instrument. So we want that to be as high as possible, right? We want that p-value to be as low as possible, right? We want to make sure that this is a statistically significant model. And if we were to try to use multiple instruments, we would want to choose the first stage regression for the instrument that has the highest F statistic, which would correspond to the lowest p-value. Okay. Now, another way of just kind of simply looking at it is you could just look at correlations, right? And look to see, well, which one of these has a stronger correlation, right? Which one of these instruments has a stronger correlation with your X variable, right? So we're just looking at the endogeneity condition here. The only problem is I can't use correlation, or I can't use, why would it be a problem to use a covariance? how could I compare across variables? Remember my covariance, what are the units? Whatever the units of X times the units of, so I might have very different units. So if I'm taking medical expenses, if I'm taking having health insurance times Social Security income ratio, that's dollars, right? Or that proportion. If I have health insurance and I'm multiplying at distant, well, now I've got distance. Those are very different units. So I would not want to look at covariances. I really want to look more like those correlation coefficients, those unitless measures. But basically something that had a covariance or a correlation close to zero, that's not going to be a very good instrument. And then we can also look at that F statistic. Generally, if we can find an F statistic greater than 10, that's going to be an indicator that it's a valid instrument, right? Now, obviously, what's the best instrument? Whatever has the highest F statistic. So we'll come down here. We'll look at those two regressions again. So here I said this is not a great way of doing it, but let's look at the correlation of those two instruments with our X variable. So the correlation with health insurance and the Social Security income ratio, negative 0.2, firm location 0.1. So if I'm just looking at the correlations on its face, it might look like maybe that Social Security income ratio is a little bit better of an instrument. It might meet that endogeneity condition a little bit more because it has a stronger correlation. But now what this doesn't account for is in my regressions, I was also including additional controls. That doesn't factor that in at all. So the correlations are like a good place to start. But if we're going to include additional control variables, so like what? The number of illnesses, age, and income. Well, I want an actual measure that looks at what that correlation is, holding those variables constant as well. So I'm going to actually run those regressions. I can still use that IV regress command. But if I put comma first, it'll show me not only the second stage results, which were the kind of end results we were caring about, it'll show me the first stage as well. So remember before, we could run that first stage on our own if we really wanted to. So that was just we're looking at health insurance. Health insurance, Social Security income ratio, and then our added controls. So we could run that regression ourselves. The IV regress command, though, we're going to need eventually our second stage results as well. So we might as well just do this all in one line, add in comma first, and we'll get both of them. So if I run this, I've got my second and first stage results when I'm using firm location as my instrument. And I've got my second and first stage results when we're using Social Security income ratio. So that first instrument, if I'm looking at its F statistic, it's 185. Is that above 10? Yeah. So this is definitely going to be a pretty valid instrument. Now, to your point, if I am thinking about p-values, which one would be a good indicator for a better instrument? I would actually want to be looking at that p-value from my first stage, right? So if I then compare that to the first stage when I was using firm location, well, what's my F statistic? 146 instead of 185. So, I mean, both of these are well above our general rule of thumb, which is 10. So both are probably good instruments, but which one based off that would I say is better? Remember, F statistics are just like any other test statistic we're looking at. The higher the statistic, what's happening to my p-value? It's getting smaller. So the higher the F statistic, smaller the p-value, that would be the instrument we want to rely on a little bit more. In this case, it looks like that Social Security income ratio slightly, might meet that endogeneity concern or condition slightly more. Now they're both very high, so we'd be, we're kind of getting nitpicky here. We really could use either one, and we'd probably be okay. And then same kind of idea. I could look at the p-value there. Well, the p-values both look like zeros, but notice what's the test statistic on my instrument Social Security income ratio? Negative 14. What's the test statistic on my instrument firm location? It's about half as much. So the F statistic or your p-value and test statistic on your instrument from that first stage, that's what's going to tell you what's a stronger or weaker instrument. In this case, both of those, the F statistic and the test statistic of the coefficient estimate on our instrument, both would indicate Social Security income ratio is a little bit better of an instrument. Okay. Any questions on anything there? Okay. So we've talked about weak instruments. What else do I want to say here? We'll keep going because I want to show you back up here to kind of prove that this is going to be the case, right? So if I try, and here I think I'm looking at, we'll use the first one, just going back to, we'll just do one instead of doing both of them. So let's look at the very first instrument we were talking about, that Social Security income ratio, okay? So we said what should be the case is if I run this regression, excuse me, the covariance of y and z over the covariance of x with z should be the estimate that we see from this second stage. So if I run just the second stage, the coefficient estimate I'm seeing on health insurance is negative 0.85. Okay. Excuse me. So what am I looking for? So here, if I'm instead using Social Security income ratio, that was the instrument we're looking at. This estimate should be the covariance of our y variables, so medical expenses, with our instrument z divided by the covariance of our x variable, health insurance, with that instrument z. Right? So we can find covariances in Stata and see if this actually holds. Right? We know the estimate we just found was from our second stage, negative 0.85. So let's see if this will hold. So here, I'm just going to use that correlate command and look for the covariance. Now, what I want is what's the covariance of y with that instrument z, and what's the covariance of x with that covariance z. I'm going to go ahead and run these. I think I've got the values here already. All right, we would say, okay, the covariance is what? 0.0312 and then negative 0.037. So if I take the covariance of y with my instrument divided by the covariance of x with the instrument, I'm getting negative 0.82. Well, it's not quite negative 0.85, but why is it a little bit off? I said in order for that equation to hold, what could I actually not do? I can't include these additional controls. Otherwise, the math gets a little bit trickier. So to kind of prove this to ourselves, let's say I don't use any additional controls. So everything's the same. I'm just not including illnesses, age, and log of income in my controls. So now, if I run this, I get what? Negative 1.17. And then now if I'm looking for these kind of covariances I have between the two, so I've got firm location. Oh, did I do this? What I want to do? Log expense, health insurance, firm location. No, this is not the one I wanted. Copy and pasted the wrong one, right? We were looking at Social Security income ratio. I was going to say, why is that off? So we can, oh, what's the name of the variable? Did I misspell something? Yes, I did. Add an R in there. Sure enough, if I run it without the controls, I get that negative 0.8217, right? So that will hold. We can prove to ourselves that will hold. It just breaks down if I include additional controls, because then there's going to be some little more complicated math there. But even with the controls, right, like using that method of the covariances, it's pretty close. It's going to be a little bit off because we added in these additional controls, but it'll still be pretty close to what that unbiased estimate should be. Okay. Any questions there? I know I've kind of added some things in there that was in the original file. Okay. We already looked through if it was a weak instrument. We kind of talked about both of them. I think I've got an example set up here. Firm location. Oh, we haven't talked about this yet, so we're going to kind of come back. So one more test, and then we'll get to, I think, maybe some other examples that maybe are a little more interesting. So, another test that we have, so we said for the endogeneity condition, we can look at that F statistic from our first stage, right? Or the p-value test statistic of the instrument from that first stage. For our kind of another endogeneity test that we can do is what we call this Durbin-Wu-Hausman test. So I'll run my first stage. All right, so I've got X, Z, and W is just my additional controls. So if I wanted to, I don't have to include W here, right? These were just additional controls, but we could include. I'm then going to save my residuals. So kind of similar to when I was saving my predicted X values from the first stage, we're going to predict our residuals from that first stage and then save them. And then include not the predicted X values, we'll use the actual X values, but our predicted error terms from that first stage. We're then going to look at, and here I probably should be copy and pasting. All right, we're going to look at beta 3 or however we write the order. We're going to look at that coefficient on our error term, right? So if we can reject, right, we find p-values less than 0.1, 0.05, 0.01, then we're going to say that this variable X is actually endogenous, right, to Y, and that we should be using whatever this instrument was that we used in the first stage. So if we run this second stage regression, it's not technically the second stage, but we run our regressions with the predicted errors from our first stage. If we can reject that this coefficient is different from 0, then that's an indicator we should be including whatever that instrument Z is. Okay. So in our example, we had, once again, I'll just kind of go back to using this social security income ratio. You could do the same thing for firm location if you wanted to. We're going to run that regression where I'm using the actual Y, actual X values. Okay. So this is kind of like our now first, sorry, I said Y. This isn't Y. This is our X value, right? This is our first stage. Sorry, our dependent, I get used to saying Y for the dependent variable, and here it gets a little bit, it's different, right? Because our first stage, the dependent variable, which usually our Y variable on the left-hand side, actually is our X variable, right, from our original regression. So health insurance was that X variable, our instrument Z, and then we said these W, these additional controls, we can still use them. We don't have to, right? But we think these things might matter, so we want to make sure we can also include additional controls. So I'll run my first stage regression. Now when I use that predict command, I'm going to come up with not my first stage predictions of the X value, but my first stage residuals. So instead of using XB, which comes up with the predicted values for my dependent variable, I'm going to use comma resid, or I think you can actually spell out the whole word residuals if you want. Resid is just kind of a shorthand. And then it'll predict those residuals, save them as a separate variable. Now we're going to use those in what looks kind of like a second stage regression, right? So now we're going to use the Y variable we were interested in, medical expenses, the original X variable, health insurance, all of our controls, but also these predicted residuals from the first stage. So if I run that regression, oh, what didn't it like? I have log income, age, illnesses here. Oh, drop. I think I forgot to do this and I used it. I did things out of order. Give me 1 second. Okay. So we run this regression and come up with our predicted residuals. All right, so we've got those there. Now, when I kind of run this regression using those predicted residuals, there we go. I ran the predictions from a different regression, which is why all those things looked like they were missing, because I forgot to run this line of code first, right? I actually have to run the first stage in order to predict what the residuals are. So once I do that, notice I'm getting that same kind of coefficient estimate we were finding before, but notice those residuals, right, for my first stage, p-value is basically 0. I easily can reject those error terms or those residuals. I have a coefficient. that's different, or sorry, I can reject that the coefficient is equal to 0. It's something different than 0. So that's a good indicator. I should be using whatever that instrument was in that regression where I came up with those predicted residuals. I should be using that instrument, right? It's like it meets that condition, right? Like I can reject those errors or have a coefficient different than 0. So that's an indicator I should be using that as an instrument. So just another way of kind of testing. We can look at the F statistic from the first stage. We can also run this Durbin-Hausman test. Both should be kind of line up. They won't always be one-to-one. Their criteria are a little bit, one of them's a little more relaxed than the other. But I won't ever ask you, like, I'll only ask you about one at a time, right? So usually they will suggest the same thing, which in this case is that we should be using Social Security income ratio as our instrument. Sometimes they might be a little bit off, right? If they're on kind of the edge. Right? I think I have an example later where that'll be the case. Okay. All right. So we rejected. So that means we should be using that as an instrument. That's kind of what I got added in there. Okay. So that should take us through every topic, anything we should need. So from here, it's just going to be looking at more examples. Okay. We'll go through one more example, and then I think I'll have something that's a little bit more fun. So let's start up with this wage. So this BQ's wage, just a free data set that we can kind of use. So it looks like you got what? Wage, hours worked, IQ, a bunch of other controls. So we'll start thinking about a naive regression where I'm just trying to predict wage using education, experience, age, and married. So if I look at the coefficient on education, maybe I want to try to predict what's the impact of getting college education, or I think here education is in the number of years. So what's the effect of having one more year of education on my predicted wages, right? Do I want to continue to keep going to college or whatever it is? Well, what's maybe a good instrument, right? So if I'm trying to predict wage, and I want to know the impact of education, I've got a bunch of additional control variables as well. So this is really the relationship that I'm interested in estimating. What is something that might be uncorrelated with the years of education, correlated with the years of education I'm getting, but uncorrelated with my actual wage? So there's an old paper, and this person with this data set actually came up with, well, what if we used parental education? Okay. Whether or not my parents have a college degree should not impact my current wages at all, in the sense of the only way that they would be impacting it might be through other things, right? But if I'm controlling for these other things, so maybe my parents having an education, maybe I came from a higher income background, but if I can control for that, that's no longer in the error term, right? So if I can control for these things that I think parental income might impact, it should be completely uncorrelated with my current wages. My employer doesn't care if my parents have a college degree, right? I mean, they don't, that shouldn't impact how much they're willing to pay me. It should be how effective or skillful or, whatever talented a worker I am. However, what do you think is true about parents who have a college degree? Do you think their kids are more or less likely to have a college degree? Even if we control for all other factors, right? Even if you can control for things like income, right? It's probably more likely, or this instrument Z is correlated with our X variable, uncorrelated with our Y variable. I mean, just honest to God, like you guys might take it for granted. I don't know everyone's background, but if you don't have like a parent or an advisor, this is why going to a good high school matters. Just navigating the application process and even understanding like, how to go through all that for a lot of people, it's a lot harder if you don't have someone kind of guiding them. So parental education, maybe this matters less now that we have a lot more advisors at a high school level about going to college, but here we can kind of think about this as our instrument, right? So we'll see. Maybe it's a bad instrument. Maybe we'll look at the F statistic and it'll be less than 10, right? But that's the idea, right? So we want something that's going to be endogenous to your own education, so correlated with it, but exogenous to that person's wage. Okay. What's another thing that might have impacted this around the pandemic? There's been other points and times as well. But anything that would like give people money to go to college, like reduce the cost, that's probably going to be policies, right? That will make it then more likely people have a higher years of education. But is changing the cost of college going to impact, going to impact wages? I can't think of a story where national or state level policies on how much money people are going to go to college should impact wages at all, right? Other than through more people having a higher number of years of education, right? So here we'll kind of use the short way of doing it. I'll just use that IB regress command. We've got our Y variable of wage, X variable education, and here I'm going to use father's education, right? So you can use parental education here. I think the way the variables were coded, I've got mother and father education, right? So you could like do a combination of the two or however you wanted it. Here, let's just look at one just to make it a little bit easier, right? So I'm going to run this regression. I'm going to put the comma first so I can see the first stage, right? So look at my first stage results. Does this look like it's a good instrument in terms of the endogeneity condition? Well, my F statistic is 109. It's well above 10, right? My p-value associated with it, 0. High test statistic of about 10, right? So looks like it's meeting that endogeneity condition. Now what I could do is kind of break this down a little bit more. If I wanted to do this, I put the code in. If you want to do this step by step, you can. There's no reason that you necessarily have to do it this way. But if I do run that first stage, just to prove, where I'm now looking at education as my dependent variable, father's education is my instrument, I'm then predicting that X value, that X variable, and then using the predictions in my second stage where I'm trying to predict wages, I should hopefully get the exact same value of negative 0.27-ish. Wait, why did I? Oh, because I'm looking at it's in a different 142. Oh, where's education? 142. Sorry, this was my first stage. I was looking at the wrong regression, right? So here was kind of my IB regress command. Here was if I break this down and do it by hand, I get the exact same estimate. Now, so it doesn't really matter which way you do it. This is probably going to be easier, right? Just a little bit less coding. Now, I've included some additional controls here. So I had experience, age, and married in there. So I can kind of try to use that covariance method again. But once again, if I include additional controls, they will be a little bit off. So if I run this regression without the controls, then hopefully it will be exact, right? So if I'm thinking about, just to kind of remind us of what this is. So if I've got here's my regression. We said that should be the same as the covariance of Y with Z over the covariance of X with Z. So we're looking at wages and education. In our instrument Z, here we're looking at father's education or thinking about his parental education. So we should be able to come up with the covariance between wage, father's education, divide that by the covariance of education with father's education, and we should be finding that same value that we just were from our kind of second stage, right? So I'll run that IB regress command without the additional controls, but using that same instrument, and I get what? 100.7. If I then look at my covariance between wage and father's education, own education, father's, so this was my Y and X variable, I get 318, 3.16. If I take, the ratio of those, I end up getting exactly 100.7. It's approximate, right? I'm a little bit off, 0.67. There's some rounding errors because I was rounding things at like the second or third decimal, but it's basically the same exact value, okay? So once again, a lot of the times we have these equations, we can prove it to ourselves using data, Okay. Once again, if I kept these out to more than the third and fourth decimal, it would be the exact same number. I'm just getting a little bit lazy with my rounding here. Okay. We'll save this for next week, just so we have another example to kind of work through. I can just have more results to kind of show you. Hopefully, so, I could do the exact same thing up here. And this is where maybe I think for whatever reason, mother's education is going to be better, right? So I can run both of these regressions. Got my first and second stage. So my father's education, that first stage F statistic was 109. If I use mother's education, my first stage 116. So that would suggest maybe it's a slightly better instrument, right? Maybe mother's education is a slightly better instrument than father's education. Okay. Any questions over anything there, or any questions related to any of this instrumental variable stuff before we keep moving here? Okay. So since I've still got you as a captive audience, and we'll eventually get to this here, but I tried to look up a few of these things to think about, and you can get creative with instruments. This is just the basics of like running through them. So I was looking up a few, which ones did I think are interesting? So I think we kind of did this one last class, so maybe you can envision it already. So I'll write out the word. If I'm trying to predict birth weights, and I think that, so this is like the amount of maternal smoking that exists, the mother's, the number of cigarettes. Maybe you could think about that the mother smoked while pregnant. We might want to know how bad that is for the baby, right? Or how bad it is for their birth weight. So what would a good instrument be? It needs to be something that is correlated with cigarette use, but uncorrelated with all the other factors that would predict birth weights. So what's maybe something that's definitely going to impact cigarettes, but shouldn't impact birth weights at all, or the health of the baby? So anytime you're worried about use of something, I'll give you another example I was thinking about. Where was it? There we go. So let's say I had like a college GPA, and I want to know how is that impacted by your weekly alcohol use, right? So there's a bunch of survey data sets that exist for college students where you can get like self-reported out, alcohol consumption, cigarette consumption, study hours, and how's that going to impact their GPA, right? I don't know, maybe there's a story where it makes you more social, you meet more people, you network, and maybe actually do better, right? I don't know. What would be a good instrument here? Something that is going to be correlated with alcohol use, but uncorrelated with anything else that would predict GPAs that isn't alcohol use. Right. Yeah, so what's something that's going to impact the price of alcohol, though? So the problem is the price of alcohol might vary with state, might depend. So what's something that's definitely going to change the price of alcohol? Taxes, right? So anytime you're looking at the use of something, a really good instrument, not cigarette, but tobacco taxes or alcohol taxes. Because taxes vary with time, they vary across states, right? In terms of, and so that's definitely going to be impacting use. But why would state level alcohol tax policies? What would the story have to be here? Something like at the same time as alcohol taxes are increased, that governments would also try to push through an increase in like educational funding but even that shouldn't impact your GPA, right? So you'd have to come up with some really bizarre story of how alcohol taxes might be correlated with GPAs. I can't think of one. So state level policies, especially things that would change prices, because that's then going to change behaviors, always a good kind of example of an instrument. Okay. Is this starting to make hopefully a little more sense as we're going through more of these examples? I'll come up with a couple other ones. I thought about one that applies to you, but we'll hold off on that one. Let's do so this one's kind of weird. Um so I found this paper and they were looking at like football success. So whether or not the team won, the number of first downs they converted. So and what they did was they said, well, we want to know what is the impact of choosing to pass the ball instead of running the ball. So I think in the literature, there's this huge thing about it's actually more optimal to pass the ball in these fourth, like close, like you think of if you watch football, it's like 3rd and 1, you should run the ball. It's always going to be easier. There's actually a lot more research that passing the ball in those scenarios might actually result in a higher completion, or like I shouldn't say completion percentage, a higher success rate of getting the first down. However, the decision to pass the ball might be because I have a really good quarterback, which then also makes it more likely I'm going to, right? There's all these other omitted variables that like it's hard to control for everything. So what would be a good instrument? Z, right? So I need something that's going to be correlated with the decision to pass, right? Well, I know things like QB quality, all that stuff's going to matter. So I need to find something that's correlated with the decision to pass, but it also needs to be uncorrelated with my success. Okay. So this one paper looked at before the play, what were the prior number of lost fumbles, right? Because these were like things that have already happened. So they shouldn't impact my current first down success, right? Like they've already happened, right? So if I'm thinking about predicting whether or not I get the first down in this play, prior fumbles don't matter. Like this was earlier in the game. But if I have more prior fumbles earlier in the game, what do you think is that team going to be more or less likely to pass the ball? Probably a little bit more likely, right? So I've got something that's correlated with my X variable, uncorrelated with my Y variable. That might be a good instrument. So another good instrument, not just state level policies, when you're looking at individual decision making, a lot of the times things that have occurred prior, right, looking at like lagged things are good instruments as well. And then I had one I was thinking about like what we could do kind of test performance. So this could be like at the college level. And I was thinking about hours studied. And then, oh, sorry. And then thinking about a good instrument Z. So I was trying to think about something that would be uncorrelated with your hours, or sorry, correlated with your hours studied, uncorrelated with your actual test performance. So I was thinking, and this one might not be a perfect instrument, and you can kind of tell me why. So I was thinking about if you had an indicator, or if the test was given during the week of Little 500, all right, would that be impacting how many hours you study? Maybe not for all of you, but my guess is for a lot, those things are going to be correlated. Not in a good way, not positively correlated, but probably negatively correlated. But the fact that there's all these other things going on that prevent me from studying, other than the way that it's going to impact my test performance and hours study, is it going to change my inherent knowledge? No. It's not going to change my underlying IQ. It's not going to change all these other factors. The only way it should be impacting Y is through the fact that it might be changing my hours studied, right? So I was thinking, if I were to look at this, I'm guessing this is probably a decent instrument, and using like big events that occur, right? And especially big events that occur randomly, it's another good way, another good instrument usually, right? So this is, I think, is a good example too, where it can impact. So when we say it's uncorrelated with Y, it's not quite that it's uncorrelated with Y, it's uncorrelated with the error term. So it's uncorrelated with everything that would be used to predict Y that isn't X. So it can still, this instrument can still be impacting Y through X. It's just that it's not impacting Y through anything else. Okay. What's maybe one reason why this might break down? So other than impacting your hours studied, I don't know, if this results in you showing up to the test half drunk still, right, then maybe these actually won't be uncorrelated. But right, I'm just trying to think of different examples and think about how we identify instruments.
So when you say that our instrument shouldn't be correlated with our instrument, how do we know if we're playing training progression? But how detail.
Yeah, so what's one thing I could do is I could actually include, like I could look at a correlation of my instrument with Y. I could also run a regression where I include the instrument in trying to predict Y. If I do that, what should the coefficient, if it's a good instrument, what should that coefficient be pretty close to? 0, right? So you can kind of include it to kind of check to see if it is correlated. A lot of the times with these instruments, this uncorrelated with the Y, a lot of the times it's just that you've got to tell a really good story. Like, there's no way I can prove that everything that could be out there that predicts Y, that this instrument is uncorrelated with, right? Technically everything in the air term. So it's hard, right? Which is why you probably don't want to use things that they seem a little wishy-washy. You want to use things like state level policies, because there, even though you don't have like a statistic you can identify that tells you if it's exogenous, the intuition or how that example, like how the real world works, you know that, I mean, I shouldn't say you know, but if we're thinking about alcohol and alcohol and tobacco taxes, how does state level policy impact some of these other things? You'd have to almost come up with a story how it would impact it, right? But these ones where there's a lot of other factors, yeah, it's hard, right? You've kind of got to be able to convince people that this is a good instrument. You almost have to be a good storyteller for that second condition. Now, I say a good storyteller. There are some things where it's like, it's just obvious. So another one that people have used. So this is a little bit more economics. So what does this look like? I replaced these, but price is a function of quantity. This looks like what type of an equation? Demand equation, right? Or you could think about it, it also looks kind of similar depending on the sign, supply equation, right? So a lot of times people want to estimate these supply equations. So there's an age-old example of like fish. Like they wanted to look at what was the, because they were worried about like overfishing. So how does the quantity of fish applied impact the price and vice versa? Well, first of all, we know there's a simultaneous causality issue. The more fish there are, the lower the price. The lower the price, the fewer people want to fish. It kind of continues to go. So we said one of the things that instrumental variables can solve is this simultaneous causality issue. So what did they use as an instrument? So what's something that might impact quantity supplied, but not impact anything else that is going to influence the price, right? So it's got to be correlated with our quantity supplied, uncorrelated. Maybe I've mentioned this, so if I have, someone can make it look like you're really smart. What's something I could maybe use in an instrument? Something that would impact supply of fish, but not influence the price through anything else. So I was saying earlier, good instruments are things like state level policies, right? Or things that just kind of like happen. So what's something that could happen that really would dramatically change the supply of fish? So what they looked at is basically weather conditions, right? So crazy extreme storms, what's going to happen to the number of boats that are out fishing? It's going to go down, right? So when they were looking at like tornadoes, I think they were using hurricanes, if I remember exactly what they were doing, like severe situations that are completely random, right? So another good instrument are things that are just random, right? But even though they're random, they're still going to impact, we know they'll be correlated with supply. How could hurricanes impact prices through anything other than the supply that's out there? Like, are hurricanes going to impact the current, I don't know, number of firms? Well, no, that is what it is. Is it going to impact the overall income of the individual? Well, maybe moving forward it will, but it's not impacting the current income, right? And so they were saying that, these weather conditions were another good instrument, and they actually were able to kind of come up with some pretty good predictions of the supply equation in the fishing industry. Okay. And then there was implications of overfishing versus, how can we use price controls to get the level of fishing to a more socially efficient level, things like that. Let me see if I had any other examples. So I think that should do it here. Oh, I was actually thinking about one today. Uh, so how many of you took so you're not Kelly students, so you would have been, is it 250, E251 or E250? It's 251 still, right? Some of the numbers are a little bit different. So let's say, how big were your class sizes? Do any of you remember? It's like 50, 100, 200,
50.
150. Was anyone smaller size? 75. So there's some variation, right? So I think about this. So for you, it would be similar. I teach a 251 Kelly student. I have 300 students. There's also some graduate students who teach sections that are like 40 or 50. So if we're thinking about, and this is something in the economics of education literature people care about, is how does class size impact performance, right? Because when you're in a smaller classroom, you can get a little bit more one-on-one kind of connection. If you're in a larger, it's easy to get lost. It's easy to like not be paying attention and not get called out, things like that. And so how is class size going to impact test performance of students? Well, the problem is if there's any type of like registration into like preferred classes, then all bets are off. But if it's completely random, that we still have variation in class sizes. So even with large lectures, some of them are like 280, some of them are 300, some of them are 270. So there's still variation in class size, but you could use as an instrument, were they in kind of one of these large lectures? And you could define this as anything over 200, right? And so there you could still exploit that there's variation in class size, but you know that because they got sorted into this section, automatically that's going to impact their class size. But simply getting sorted into that section shouldn't impact their test score other than the fact that they're now going to be in a different class size, right? So random selection or random assignment into things is another really good instrument. You could do this with a lot of things probably at the college level where they're just completely random. Now, why do some of these things break down? What if it's people who are on top of their they were good time managers and they were looking at dates? Well, maybe the people that get in these large lectures were people who are actually slacking off and weren't registering for classes as when they immediately could, right? And in which case, well, maybe it would be then impacted with test scores. So that's a good example of one where maybe it'll break down. Maybe this isn't a good instrument. And that exogeneity condition is going to be something you would have to argue. There would have to be completely random the assignment, because if it's not, well, then maybe some of these other things you're not controlling for, like the responsibility of the student, that might lead them to be in these larger lectures because they didn't get registered as quickly, and that might also be correlated with their test performance in that class. This doesn't just have to be econ, it could be whatever class you're kind of thinking about. Any other questions? Is this hopefully, I don't know, hopefully make a little more sense. So I think we'll wrap it up there today. I've got an in-class quiz. You know, the other thing I was thinking about this actually today before class, it wasn't going to be one of the examples that I used. But I actually was thinking about how class size impacts cheating, right? If I had some ability to kind of measure and had some data on that, because like my large lectures, sometimes we're all in like one big classroom. Sometimes it gets split up into multiple rooms and I assign it based off your last name, which doesn't rule out cheating, but it means that if you would have to be, you have to randomly be cheating with someone that has the same last name or to get sorted into the same room as you, in which case then I would be correlated with my X variable, maybe not my Y variable. Anyways, so one last quiz, all right? Should be an easy one because I'm just asking you for the magic number for the day, which is out to the first decimal, 232.7, okay? All right. Maybe I've got some, let's see, I think I have it saved here. Maybe. I've got one more thing, I think sitting here. See if not, might pull it up real quick. So 232.7 should be kind of what we're looking at there. So 232.7. And then we got some cuteness that we'll look at here. Maybe. I was going to bring this to class on Tuesday, and I forgot. So a little bit delayed. But happy Easter. My son's hamming it up and being too cute lately, so I gotta brag on him or show him off a little bit. So 232.7 should be that quiz score number. Other than that, you guys are good to go. Should have everything we need to do that sixth and final problem set. The other questions, feel free to reach out to me. It'll be due at the end of the day on Tuesday. Okay. All right. Enjoy what's left of the week. Nice weather, and I'll see you guys on Tuesday.